Alright, hey guys, what we're going to do today is have a look at group 0, which involves all of the noble gases. You can see some examples of noble gases here. On the first little slide, we've got obviously helium, which is used in balloons to make them, because they're lighter than air. In the middle here, we have a neon light. Neon is a noble gas as well, and one property that all noble gases have is that they glow when they have electricity running through them. And finally over here we have a krypton laser. Now all noble gases are very, very unreactive, so that's why they're great for uses in things like high-powered lasers. Now, anything that's in group 0 is right at the end of the periodic table. Those are all the noble gases. So we're talking helium, neon, argon, krypton, xenon. They are all very light and colorless. And most importantly, they are very, very unreactive. They do not do any chemical reactions. And quite interestingly, noble gases glow when electricity is passed through them. So let's have a look at some of the uses of the elements of group 0. Here I've got some elements, what they're used for, and a reason why. So let's have a think about what this is. Well, we know helium is used in balloons, but why is it used in balloons? It's because it's lighter than air. Neon is used in neon signs, and the reason for that is that it glows with electricity. Argon is used in double glazing, and that's because it is an insulator. And krypton is used in lasers because it is unreactive. Right, one of the things that we can do with noble gases, or anything in the same group, is look to see how that look to see what happens to the properties of the things in that group. So if we think about the properties that these elements are going to have, we should be able to plot a graph and work out what something's going to be. Let's do a bar chart of this information. So the thing I'm going to look at here is what element is and what the relative atomic mass is, and there should be a nice pattern that emerges from this information. If we plot this data as a bar chart, which I'm just going to do now for you, we'll have helium over here, neon will be up here, argon is here, and then xenon ends up here at 130. You can see that there's a very clear pattern, and that they increase by about the same amount each time. So if I want to predict what the atomic mass of krypton would be, it would be somewhere in between argon and xenon. There's a real clear pattern of what's going on. In actuality, the mass of krypton is here at about 81 or so. Now, here's all of our group 0 elements. Remember, they're colorless, they have low melting and boiling points, and they do not conduct heat, and they do not conduct electricity. And they don't do any chemical reactions. And interestingly, because of that, they just exist as single atoms. They don't do any reactions. It's really easy to understand this if we have a look at what's going on in their electron shells. So we've got to take this all back down to electrons. Here you can see my noble gases. If you note the picture of all of them, they all have a complete outer shell. The outer shell is completely full. And this means that they are already stable. They don't need to become ions. They don't need to share electrons and become covalent molecules. They're already perfectly fine. And so therefore, they don't do any chemical reactions. They're really, really boring. Right, let's have a go at thinking about these questions. Pause the video now, try and answer them, and I'll give you the answers in just a second. Just pause now. All right, hopefully you've got an answer written down. Why is argon unreactive whilst potassium with one electron is very, very reactive? Well, that's because it's really easy for potassium to lose that one electron and become stable, like a noble gas. The noble gas is already stable. How do the properties of helium make it useful in weather balloons? Well, helium is lighter than air, and that means it will float well above the Earth's atmosphere, so it can get information about what the weather's going to be like. Not just that, but it's incredibly unreactive, and so it's not going to be damaged by anything that could, and suddenly explode in a ball of fire. So last question, explain why argon can be used in fire extinguishers. Argon is really, really unreactive, and so if you spray argon on a fire, it's going to stop the oxygen from getting there, and therefore it will smother the flame, and you won't be able to get you won't be able to have the fire going anymore. All right, thank you very much, guys. Have a good day.